Welcome to my new video. Now we are going to make a voltage regulator with some diodes. This is a spin-off of the last circuit in my previous video. We are gonna make use of the three diodes to create a simple regulated low voltage output equal to the sum of the threshold voltages of the diodes. So now here you go to your library. And now we are going to take diode called, the device or diode. That device is named 184148, and we're gonna take this one. Now I'm gonna take a resistor. Just type in RES and take a resistor, and now we are gonna take one lamp. It doesn't matter, but just to show you some things, because there's a lot of small current in this particular circuit, so I can't measure the current in Proteus because the current is about 3 milliamps approximately. Okay, now when you put like so three diodes here, we have okay, now you can connect them. Okay, now I need a resistor here. Disconnect this, and I need a power source. So here, now I'm gonna show you something. Gonna change the value of the resistor to 1K. That's 1000 ohms, and I need a ground, and here I'm gonna put a voltage about 5 volts. I need a ground. I already show you the conventional labeling of power supplies, and just gonna take some DC voltmeters. So when I run the program, as you can see, I'm gonna measure the voltage across all these diodes, and I'm gonna measure the voltage across all these three diodes. So for the first part, and I'm gonna just here, I guess. Nope. All these diodes are gonna have the same voltage dropout, and I'm gonna put one voltmeter that's gonna measure the voltage between the first end of the first diode D1 and on the cathode of the D3. So when I run the program, just a second. Okay. Now you see that there are 0.7 volts voltage dropout on each of these diodes, but from here to here, from this point to this point, you have 2.10 volts steady voltage from this side to this side. So now when I want to put, for example, a lamp in parallel like this, I will have here a steady voltage of 2.1 volts on this battery. Just a second, I need a ground now. I'll put nominal voltage on this to 2.1. It doesn't matter now, it's just I'm just showing you something. And here you have 24 ohms is the resistance. So when I run the program, you will see that there's it doesn't glow very good. That's because there's a high current, and there's a lot of current amount out of drawn, and that higher power critical voltage sources uh, because this lamp is has a lot of small resistance, it's gonna dissipate a lot of power here, so you won't have a 2.1 voltage here. So what am I going to do is I'm going to increase the resistance of the lamp. You don't have to, it's not usually done by this, but you can always put a resistor in series with the lamp, and you can get a desired resistance in this circuit. And I have to say that this lamp should have a resistance, or in this circuit where there is a voltage regulator, the resistance should be less than this resistor here, but it shouldn't be a lot less, like 24 ohms. So let's say I'm gonna put 900 ohms, and then you will see when I run the program that you have a smaller voltage dropout. So here you have that now a lamp is glowing brightly than when it was 24 ohms. I know it's kind of strange, but yes, because uh, it draws a lot smaller current now. The voltage is now steadier. Of course, it is now 1.95, but it now glows brighter. And when I put, for example, 1K, I think it should be a little smaller than, yeah, that's it. I mean, you don't have a steady voltage regulated. Uh, this is uh, this is just to show you that it can be done, but it's not usually used in practical ways, because for voltage regulated circuits you will typically use a Zener diode or a special regulator IC, integrated circuit instead. But that's gonna be in my next lectures. In a lot next. I mean, not in the future, I'm gonna do IC regulated circuits. So this isn't a practical way, but it shows you some basic principles right over here. So this is it for this lecture. Thank you for watching, and see you in my next video. Goodbye.